I really didn't understand like this until I actually understood like, wow, this shit is true. Like a lot of globalists they can't even defend their own model. They cannot defend the heliocentric model. It's really hard. It's honestly hard for them. If I was to even go back to convert myself back into a globist, I wouldn't even be able to know where to start to how to defend this because it's not true. I mean, I don't know. In my defense, I just find everything about it funny.
Well, it's hard to defend something that you don't know anything about either. That's the thing they
Okay,
keep
well,
running into.
haven't we been taught this our whole life in school though? So how would you say we don't know anything about it when we've been taught it our whole life?
Well, I
Think
mean,
about it.
the Globers who would argue it don't know anything about it. The dimensions,
I'm sorry. I thought you
specificity.
meant. Okay, I see what you're saying. My fault, sir. But yeah, right, exactly. This is what I'm saying. Like, I don't know. Funny.
Right. It's only when you try to learn about it that you end up where we are in the first place. So the people defending it obviously haven't looked into it, I would say.
Exactly. No. So right. Good point. Very good point.
So
Absolutely.
what did you learn that the rest of us didn't?
Was that question for me or Shane? What were you saying that to?
Either one of you. You said you learned something when you looked into it. I'm curious what you learned.
Well, let's think about it, man. Let's talk about how water does not curve unless it's in a container.
Water doesn't curve unless it's in a container, so it curves in a container.
It
Okay,
has to be
cool.
contained, right? But it's leveled without one, correct?
But
So
then it
therefore, tell me
curves.
how
All
it's
right.
curving around the ball, around the globe, and explain this to me in your most scientifically explained method, please, for all of us. And there's very a lot of intelligent people here that will listen to you too. So please,
Yeah, it follows gravity.
follows gravity.
By
Yeah.
gravity, do you mean the equigeo potential of the geoid always perpendicular down or
When
something
we're
else?
talking about water
That's
and
that's
you bring
close.
up
That's close
gravity,
enough.
it's
Yeah,
funny
I
how you
can go
don't
with
bring up
that.
density
But
or buoyancy into this at all, or anything of that, or anything of
buoyancy
that nature.
requires gravity. You can't have buoyancy without gravity. If you don't understand that, then you didn't understand something when you left the globe.
So you need
Maybe that's
gravity to
why you
have
left the globe
buoyancy,
because you didn't
is what
understand
you're
anything
saying.
about it. Yeah, gravity requires
Explain
buoyancy.
this, please.
Buoyancy requires gravity.
Explain it. Since you're making this
Bu-
claim, you're making the claim, Scott.
buoyancy is heavier fluids pulling down harder than the lighter fluids, therefore pushing the lighter fluids up.
Are we all in agreement with this?
Or any lighter density object actually. Could be a boat. The boat floats on top of the water because its density is less than the water. And you can find out that you can verify that, right? Because you can find exactly the mass of the boat or the weight of the boat by exactly the amount of the water it displaces.
Scott is exactly right. I want to second that. You can't have density without gravity. And yeah,
Yeah, but
that's exactly
yeah,
right.
Well, you
maybe that's something you didn't understand when you thought you understood the
Again,
globe, but you
you're
clearly didn't.
bringing a theory into a concept
well,
that's is not
No,
working.
it's
you
just a fact.
guys are talking
It's just a
about
fact.
the measured average of the downward acceleration, right?
You
The
cannot
only
use a
cause that
theory
you're going to
to
say is that's not gravity, right?
you
If
cannot
you do the
bring a
same
theory
thing,
into prove in you cannot bring a theory into claim to have evidence for your claim, sir. It just
There's
doesn't
no
make
theory
sense.
there.
plus
There's no theory.
you can get that acceleration just with height equals half at over plus velocity and time, right? So there's no need for that g. If you're checking that buoyancy can't be
Thank you.
calculated without that
You can
average
get what? You can get
acceleration,
what from
then
where?
sure. We can do a kinematic derivation to determine 9.8 point meters a second squared.
I'd like to see that. Can you do that? Can you do that for me
Constant
right now?
acceleration and time, bro. So it's nothing to
Cool,
do with
cool,
g.
cool. Do that for me right now. You said you can. It should be easy. Go ahead.
But you think we don't have a meme, bro?
Yeah, go ahead.
Boom.
No,
So,
no, I don't want a meme. I want you to explain what you just
yeah,
said.
I just explained it to you. Now that we've declared that you actually don't need anything called g or gravitation, you only need the measured agreed upon average acceleration, then what do you mean about
Where's
can't
the
define
acceleration
buoyancy
come from,
without
man?
gravity?
Where's the acceleration come from?
Do you
And why
want
is
to
it only in one direction? Why is it only in one direction? And
Yeah.
where's the force of acceleration come from? Why is it there?
That's a whole different question, man. You're trying to
No, it's
denote
not.
a
It's the same
mathematical
question.
formula by using something you didn't invoke and understand, right? So,
No, I love these
It's the
equations.
same
I
question.
studied them in high school.
Yeah.
These are kinematic equations. Like,
okay, then when you say gravity, right, what are you referring to? Do you mean the reduced form of mass attracting mass that Newton stole from Kepler with a kinematic equivalence that can be reduced to a form not including mass at all? Is that what you mean?
You know, if you
Dropping
use big
bombs.
words, it's not okay. I'm gonna just blow your mind here.
I doubt
If
it.
you could use that equation to describe any kind of attraction, but if you are dropping something, that equation perfectly describes the thing going down. So it's gravity. But that acceleration can be used to describe if you have two magnets and they're getting closer and closer together, the speed at which they collide with each other is also described by that equation. But it's a gravity. Yeah.
You guys are talking
So do
about
you think
buoyancy. You're saying that buoyancy requires gravity. I'm saying incorrect. It only requires the measured agreed upon average, which we don't deny and all know about, right?
Average of what?
That can be also
Where's average?
kinematically derived from nothing to do with gravity, like I already showed you in that meme with those variables. That's just physics, right? Secondly, do you know where the mass attracting mass ridiculous misnomer comes from? Do you aware that Kepler described the periodicity of the orbits with exactitude before any of this happened?
Where is average in this equation?
What?
You said something about average. Where is average in this equation?
What do you mean average?
You said average. You used the word average.
You said
Scott.
9.8 average. You said 9.8.
9.8, yeah, meters a second squared is an average, agreed upon average. It fluctuates all over the Earth, doesn't it?
Yes,
He's
because of the
lost.
mass of the Earth, there's different amounts of thick, like different parts of the Earth have thick iron underneath you, or if you're over like really soft soil that has less mass, because they're all gravity. They're all gravity.
Okay, well, your ad hoc explanation aside, right? That's why I said average, because it's different all over the plane. So we're going to say something is a constant. It's not, right? That's why I said average. Now, get back to the kinematic
There you
derivation
go.
of the same average, bro, right? If you have height, right, you give 1/2 AT squared. Do you guys know what that is? Acceleration, right?
Yeah.
Time for the ball to fall to the ground plus VT would give you an exact derivation when you're solving for acceleration. would
Derivation
equal
of what?
times the height over the time squared, bro. Now, figure that out and get back to me.
A derivation of what? That 1/2
Yes.
AT squared plus VT plus sometimes X naught is just the distance something has gone over that time.
Very good, Scott. Now, what would that yield if I were to try to solve that for realistic forces?
What do you mean? Solve it for what?
Is Scott the guy we
You're
started
speaking
with?
gibberish.
No,
Yeah,
I'm
you're
just.
not
Literal
actually
gibberish.
making-
You're speaking
you're not
literal
actually-
gibberish. Solve it for what?
You started by invoking G, guys, right?
Wait, you said solve this equation for something. Solve it for what?
Holy crap.
You have no idea what you're talking about, do you?
Yeah, Scott, you've totally put me to shame. I'm actually embarrassed. I'm definitely not tired of talking to you. That's for sure.
So buoyancy is gravity. Let's go back to that point.
There you go. That's how we started, right? So you said that you can't have
There you go.
buoyancy without gravity. Now, we've showed you that you can actually determine that acceleration without any mischievous, quote, gravity, right? So then how do you mean
No, you haven't.
you need gravity? Of course I have.
Wait,
No,
hold
you
on.
haven't. You have no
These-
idea what you did. You don't understand what you put up there.
Of course I
very
do.
clear.
That's why I
You have no
explained it
idea what you put
and
up there.
used my words and then showed you the meme and then again recited it, right? Read through all the variables and
But
what
you
their
don't understand what it
equivalents is.
says.
How would you
What does that meme say? What does that equation stand for?
Wait, hold on. I want to try. Shane.
All right.
Shane, that equation describes motion, right? Now, the fundamental question we're asking is why does the object want to move in the first place? Why?
Right,
Like we can use.
but you've never explained that, right? You have this ridiculous gravity field which supposedly proves the cause never happened, right? So that's why we're sticking to the agreed upon average, which is what you invoked in the first place. Am I going crazy?
No, you're just not making any
I
sense.
think
You're
you're already
making.
there, but go
Yeah.
ahead.
Well, guys, the gaslighting aside, right? Because I literally have a huge self-image with what you guys think of me. However, right, when we started by invoking gravity to explain buoyancy, that was fallacious and incorrect. You guys agree?
No.
No.
Well, then how come we can derive gravity without any of that, right? We can derive
can't.
what's
Describing.
called
That's not gravity.
gravity.
That's-
Of course it is.
You
Of course
can't
it
because you
is.
didn't.
Of course I did. Jesus.
You didn't come close.
Okay, so Shane, that equation is using velocity and distance to calculate final distance, displacement. There's
No.
nothing in there. That's literally okay. You're funny. I thought you knew what the equation did. Look at the variables. Look at the very meme that you sent me.
What's
It's
the
asking for
resulting?
no, hold on. Look at the very meme you sent me. It's asking for initial velocity, the amount of time, the acceleration downward, and then at the end, h, the height. It says height of the ball above the ground. But you can use this equation for any attraction, right? You're looking for displacement.
Which one are you looking at, bro? You looking at the meme?
The one you sent me. Here, let me reply to
Yeah,
it.
no,
This
that
one.
solves for acceleration.
No, it solves for distance. H is distance. Height.
Acceleration.
No, you're not. You're not
Yes.
solving for acceleration. Acceleration is part of the equation.
Oh my god.
Oh, the
You're not
bottom part.
solving
He's
for
talking about the
thing
bottom
that's
part.
your variable, man.
You know how like algebraic equivalence works, where you can balance equations and solve for any of the missing ones? You guys are familiar with this?
He's talking about the bottom part, Scott. Look at the very bottom. It
Yeah,
says then
you
solve
talk
for
about
A.
rearrange. Yeah. But it doesn't do anything for him.
Oh, but so wait, so it does solve for acceleration or not?
No, it doesn't.
Oh, so you're just gonna baselessly claim it doesn't?
No. I'll respond.
You did.
I'll
It was a negative and retarded.
How is
let
H
me
a
try.
constant? It's insane.
So you're solving for A given some time t and a distance traveled, right? But this is that's literally what it's equal to.
No, height.
Okay.
No,
height,
distance invoking.
Which is
Oh
the
my
distance.
god!
Sorry.
It's in this equivalence. It would actually be very different than height, right? So that's why we carefully say height.
What?
In linear distance, would that still be height, right?
Yes. Well, is there any
no.
other distance? Is there any other distance that this equation is considering? All of the A, the V, all of them are in the vertical direction, right? Is there any horizontal mention anywheres? No.
No.
So I'm just going to use yeah, exactly. So I'm just going to use the word. I'll use the word height so that you won't get confused. Okay.
Well, that would be correct. I'd appreciate it if you were correct.
So you're solving for acceleration due to some change in height and time, is what this equation is doing.
Yeah.
It has no it's not proving or disproving anything. It's just a relationship between.
That's because you've never used it, right? You've never used it.
I literally have. Yeah, in high school we use this equation all the time. Like this is literally high school. This is high school physics.
What's the resultant unit?
It depends on what you're using. Kilograms, pound force. Yes, it does. Pound force. It depends on your metric or imperial units.
So we started with buoyancy needing gravity to define it. Incorrect and fallacious. You agree now?
No.
Oh my god. All right. So
what happened to VT in this equation? You're talking about balancing equations like algebra where you just cancel out VT for no reason. Just decide we don't need it. We're going to let go of it because reasons.
Velocity 0. Would you need to carry it kinematically through an algebraic expression, homie?
Why is velocity 0?
Jesus Christ.
Why is velocity 0?
Did you even read the thing you're trying to refute? Is it going to hurt you if you look at it, or are you just going to swing wildly until you land something?
Well, the thing is you're solving for a very specific case. The reason why you're assuming V naught is 0 is you're saying that there's no initial velocity, which is why you can get rid of that term. But like I said, you're solving for this very specific situation. It's not proving anything, and furthermore, it has nothing to do with buoyancy. You're just talking about acceleration here.
It certainly doesn't have anything to do with buoyancy. That's correct. But if you were to plug in real time, like height and time there, you know what that would result in? 9.8 meters a second squared down. That's why it's relevant, and that's why I put it up there, right? And that's why I said you've never used it, because obviously you would figure out the actual average acceleration can be derived that way. So that's the only reason that's up.
In high school, we had a ramp, and our teacher said if we can guess the distance the marble flies off the ramp at, we get extra points on the quiz, and I did it perfectly. I have used this equation, man. Like
Gold
this
star,
is high
I believe you. I believe you, except you didn't know any of the way I applied it. You weren't familiar with the concept in the beginning. You balked wildly.
Neither are you.
Did you guys want to go back to the erroneous root of mass attracting mass? We can do the Newton's law of gravitation equation can be reduced to something without mass at all, and then you can try to figure that out.
To see that.
Yeah, good luck with that one. Let's hear that one.
No problem.
Though, given how well put this first argument was, I'm kind of scared, low key.
Yeah.
To see how you start talking about other equations, because if you don't understand this one, then it's just all downhill.
You think I don't understand?
What's at school of gibberish?
No, I don't.
You think I don't understand the thing that I'm able to eloquently defend, describe, define the variables before and after, and you decided that I don't understand it?
You don't understand it.
You may have convinced people here you understand it, but you're not going to convince anybody who knows what they're talking about that you understand this yet.
Well, sure. Show me that you know what you're talking about, Scott, and tell me why this doesn't work. Go ahead.
What doesn't work?
you have Newton's gravitational force, right? You have G, right, equals what? Over the force of m1 over m2 of r squared, right? And we can reduce that to
FC. The fuck is FC?
nope, almost. Follow it all the way.
It's just more gibberish.
No, it's physics, bro.
It's more gibberish.
It's physics you don't understand.
Yeah, you explain it then. What is it? What's it saying?
Sure. Do you want to really have that?
Yeah, sure.
humiliation? 'Cause
Explain what it's saying. Yeah.
we can totally go through that and ruin it for
All
everyone.
right, let's
However,
totally go through that.
when we reduce it down to the form that it is there, right? What we've done is made equivalent the centripetal force and gravitational force, quote, meaning that would cancel out. So how would you define a mass attracting a mass as
Why'd you do that?
force? Shut up and let me listen. Shut up and let me speak. Why would you define the mass attracting a mass as a dynamic force when the variable of mass has been eliminated completely? And the reason, of course, if you understood your own model, would be that the force determining the orbit isn't the object in motion, but of course the object is traveling around, therefore it's in free fall. So of course that wouldn't actually affect the path of the current motion, right? So if you knew the variables and knew what I did, you could understand how I reduced it to nothing wouldn't affect you, right? So
just explain the equation.
I found,
if you can, which I know you can't, but I'd love to see you try.
You don't think the periodicity for a circular orbit can be expressed as what I have it there with 2 times pi over a times a over t, right? And then you can just use your algebraic
equation,
which leaves you t squared equals k times a to the third, which then derives, right, m times m over r squared equals m, which would just be 4 times pi squared over a, which is all over t squared, bro. And finally, right, the relevant result, g equals 4 pi squared over k, which finally give us, oh my god, the reduced derivation of Newton's law, which is just, in essence, Kepler's law of optic periodicity.
read the question.
Pure, utter gibberish.
Cool.
You said nothing that any basis in reality or any sanity
Right.
even.
Shane, if you actually
Just
understood
words.
Shane, if you actually understood it, you'd be able to say it slowly and actually like communicate rather than going through a whole rant without actually like, you know. I think you're relying on the big words and speeding through it in order to make it sound like you actually know.
Yeah, because
Like,
most of what I do is
we
to
can't
how
actually
you
attack
receive
it.
it.
We can't actually attack it. Like, go step by step. What's the first point you're making, man?
Well, again, in this tap dance, we started with you guys saying buoyancy requires gravitation.
Explain your equation.
Incorrect, because we've already derived that same acceleration kinematically without employing g. Secondly, we're attacking the nature of g, which would be mass attracting mass, by attacking Newtonian's law of gravitation, right? That's not irrelevant, off the table, crazy, exactly related. So when we reduced it back to the form without mass, right, to try to
How do you not understand that?
It's a fucking nut.
I'm listening to him. I'm when we reduce it without mass, I'm looking at the equation with Change My Mind guy, right?
So when we
Change My Mind guy?
When we reduce it to that form without mass, how can you say that mass is a dynamic force causing mass attracting mass when mass isn't even present in the equation in the first place?
I'm trying to understand what this actual equation like.
I know, but this is like the crux of the heliocentric belief.
No, it's not.
Of course it is. You started with gravity, but you don't understand gravity. That's why we're here, bro.
Shane, and this is actually a thing I see with a lot of flat earthers is
Go ahead, educate.
No, they'll explain physical phenomenon by pointing to an equation and say that proves it, but you're not proving the physical phenomenon. Like, stuff still goes down, buoyancy still works, but you're just
sorry, you just made a claim. Who says that?
Shane is saying gravity.
No, you just said this is what I see commonly with flat earthers. Can you
name
name something?
Yes.
Can you name something?
Shane,
Go ahead.
Yes. Shane is saying that buoyancy is not
not what Shane's saying at the moment. You said this is common with flat earthers. So give another example of what you just claimed.
You shouldn't have said that, Maximum.
Like,
you stepped into
okay,
it.
no, I will.
Take it back. Just take it back.
Hold on. I'll give one more example. When I show a video of a boat going bottom up, everyone starts giving definitions of the horizon or line of sight, but they don't actually explain why the boat goes bottom up.
What's
They
that
just
got to
gave
do
it.
with the math? What's that got to do with you said flat earthers point at mathematical equations and say this proves the flat earth. Now,
Yeah, they
the
will.
example that you just gave was not, that was about the horizon and nothing to do with an equation.
Timbo,
Yeah. So,
you have no equations for the horizon? I'd be
Of
shocked
course,
if you don't have
yeah,
a
of
single
course, but
equation.
we don't just point at it and say that
Yes, you
proves it.
do.
right? We
That's a
didn't just
drop over distance equation, isn't it?
yeah, well, we didn't just point at it, right? I danced on it, derived it mathematically, reduced it, applied my own derivation, and then showed you a reduced form. So pointing at it would be like rough, right?
Like
Yeah.
that's my whole point is you're just pointing at an equation, not explaining the phenomenon. You're saying
Don't
these
say
numbers.
all flat earthers do it.
Okay, I'm sorry.
Yeah.
I take it back.
All right. Good. Thank
Nice.
you.
Yeah, I was just trying to show you guys with your own stuff why what you say is dumb, right? Because again, buoyancy can totally be defined without gravitation. That was the whole point.
Well, you failed then, if you're trying to show us anything.
Not you personally, Scott. I don't think you're capable of learning, to be honest. But yeah, like generally to the public, sure, I think someone might have learned something.
Yeah.
Insults aren't arguments. This is probably why no one will ever even try to contest that.
Because you don't understand it? Well, so not only do I speak it, right? It's on my database, it's published, it's on Twitter, it's all over the place. It's literally a well-constructed argument and then
Yeah,
backed,
you're
sourced, and
spreading
cited.
policies.
Okay, let me go back to this equation. Let me see what's truly going on here.
Oh my gosh.
You're really going to try, huh? Good luck, man.
He's really
Good luck.
sticking to it.
Yeah,
He doesn't
know.
explain physical phenomenon. He'll point to an equation. Let me see.
No, I detailed every variable in the equation, every step of the breakdown, and when we started, right, from memory, told you what Newton's law of gravitation was that we're going to be deriving. So
Shane, if you understand it so well, why can just tell me why do things go down then? Without resorting to, yapping really fast about Kepler, why do things go down?
you want me to give you the universal replacement for the theory of gravity?
Nope. Just in English. I don't need Kepler. I just want you to explain why things go down.
Density, buoyancy, and viscosity, with the general electric nature determining the very loose vector of down.
I'm with that.
Why down?
Well, because of the electric nature of Earth, right? That's what we're saying, because that determines the vector only, which is, a vector is what? Direction and magnitude. So we can have a directional vector with a very low magnitude that would yield the downward direction. That's what I think happens.
You think the downward force is caused by electromagnetism?
That's not what I said. I said buoyancy, density, and viscosity, and then I said loosely, very, very clearly, with specificity, that the vector, which includes magnitude, would have to point down. Now, that magnitude is very low. That's what determines the vector. Anyway.
But I asked you why down, and then you said, the question. Okay, buoyancy. I'm saying buoyancy is still caused by gravity, but even if I say that it's not, you're saying, oh, the vector goes down. Still the fundamental question is why down. That's still the fundamental question.
That's already been answered, right? What determines the vector of down? The electric charge of Earth. That's what
electric charge.
down.
That's what I'm saying. You're saying there's an electric charge.
But then you said, you think electromagnetism makes things go down. Absolutely incorrect.
Well, electricity and magnetism and light are all the same phenomenon. It's the same. It's two sides of the same coin.
So when you say what causes gravity, and I say density, buoyancy, and viscosity, with the electric nature determining the downward vector, right? That's my actual answer.
No, they don't. Why does water flow
Dracula
all the way up to the leaves on the tree and the buds at
You
the
just
top
regurgitate
branches
what other
on the
people
tree?
say.
Me? Is that what you think, Diabetes? When I have all my own, well-crafted arguments and understanding, is that what you're gonna stand on?
Where is your electricity when water is flowing all the way up to the top of a tree?
Or to be technical, you know, water can be alkaline, can have electromagnetic property.
So this
You mean the branches at the top of the tree, they have electromagnetic properties?
Did I just say the water? I'm pretty sure I just said the water. Water can be alkaline and has electromagnetic property. Yes, I just said that. I'm sure.
The water has electromagnetic properties. What are those properties? Tell me.
Water can be alkaline. Simple as that. It's water is electrified. Can be electrified.
Oh.
To break it down simply for you.
Electrified.
Hey, Shane.
We're not talking about electric, all right? I'm not talking about pure electric that you see from a freaking lightning. I'm talking about electrons,
Really?
photons.
So how can you electrocute water?
My God. Then I just tell you, I'm not talking about electric that plug into your fridge. I'm talking about pure electrons and protons.
So Shane.
Water can be alkaline. Have you ever heard of alkaline water, sir?
You said water is
all right.
can
Next
be
next conversation. Who's next?
Not next. You're making fallacious claims. The most darndest things. I mean, not even kids could say such darndy thing.
I'm not even sure which side you're on or what you're talking about, to be honest.
Well, you guys are saying like, oh, if I have like a giant battery, I'm attracted to the battery because it's got electric potential. It's got, you know, negative charge or whatever. Like
specific misinterpretation because you're unable to handle the actual argument.
No. Oh, Shane. Actually, I did want to ask about. So this picture, the change my mind guy, big G and big M are still in that equation.
Which point to the simplified form for me?
The bottom line, right, with the arrow.
Yeah.
That's the simplified form. Big G and big M are still in that equation. M is the other body. Is the other.
I don't know why they're laughing. That's literally in the equation.
Yeah, no, you're right. M is still there. I forgot to reduce it out, dude. Absolutely, you got.
Well, then reduce it further. And by the way, also, this equation, what you're doing is your FC stands for centrifugal, right? And that's why you have omega, because omega stands in physics for rotational velocity times r. And then you have 4 pi r, which is also, like, I see what this equation is doing.
I mean, it's cool that I ran through it and said all that, too, I guess, right?
That's all
but
true.
I actually,
why are you guys laughing?
I actually explain it, though. You run really fast through words.
I explained it really quickly, yeah.
Anyways, you still have big G and big M in that equation, so.
Incorrect.
It literally is right there on the bottom. You want me to save it and post it?
You're looking at the wrong part of that reduced equation, right? So here would be the actual one, right? It just retains the description of the periodicity.
What is the reduced form? I'm looking.
Do you know which portion describes the period?
Periodicity is
yes. Equivalent periods between a bracket of time, right? So you have M, G, and M give you proportionality to the periodicity of the observation, meaning that's the backbone of the governor of the orbit. And that's from Kepler, right? Which is why what we actually did was reduce Kepler down to Newton to show what Newton did when he just bogarted Kepler.
Okay, if you say like.
Sorry, what are you guys talking about? What in particular?
He keeps saying the word Kepler and Newton without explaining.
Yes, because they're just regurgitating the words.
No, Kepler's law could be derived. It's not regurgitation, right? It's a complete understanding. That's why I'm here with specificity and directly addressing each one of your points.
Well, you're okay. Well, like I said, there's still G and M in this equation. Second off, you have to explain why you can reduce it by centrifugal. FC equals mass times R times omega, which that's centrifugal. You have to explain why you can just reduce, because that involves a rotating, like that's talking about rotation, not just straight down.
Yes, it is. That's why I was able to remove it entirely when I equated it to the supposed gravitational force, right? I'm glad we're on the same page.
So he's trying to derive Kepler's laws from Newton's universal law of gravitation.
There you go.
Hey, Nate, you just jumped into the conversation. Why don't you just listen for a while?
It's a well-known thing that this is like equivalent or reducible, right? For 400 years, they knew this.
I think that's true. I mean, I remember learning about that in physics, so I
But
don't.
they still got they still got G and M in it.
No.
Tell me, okay, reduce this equation further. Do you want me to save the photo and send it back to you?
Here, maybe this version will be easier, right? It has the steps broken.
You should really
Or this
consider
version
using,
from the paper where we pulled it from in the first place.
you should
Is the
consider
bottom
using
one
right.
final? Is the bottom one final? Is that the final equation on the very bottom?
Which portion of that do you think is the final reduced?
The equation that says, thus, Newton's law of universal gravitation can be derived from Kepler's laws.
Yeah.
Is that the final equation? Because you still got M1 and M2 in there.
Yeah, no, there's no M in the final reduction, man.
It literally, I'm looking at the photo right now. The final equation, the one above the sentence, thus Newton's law of universal gravitation, that sentence, the equation right above that, has M1 and M2.
Right.
It's the first two variables.
Yep. So in the periodicity, which one describes that? Because that's what we're left with, right?
No. Periodicity. You're trying to prove that mass doesn't involve in this equation. You're moving the goalpost. There's mass in this equation still.
No.
Okay.
No. Right. So you have mass, which is the planet times its radius, which times its angular velocity squared, which is where we got that. And then you have the angular velocity, which would be 2 pi over t, where t is the period or periodicity. And from that, it's how you derive Kepler's from Newton's, right? When we reduce the mass, it disappears and cancels. And that's how we know that it's actually not required to be a dynamic cause of anything, because G and M give you that proportionality to the observation, that they don't actually account for mass attracting mass in this equation. That's what the point is, right? And not in any meaningful way, or we wouldn't be able to do this. Right? If it's a dynamic cause, how can I kinematically remove it?
You're saying just because I could do algebra, it proves that, things should not go down, or I don't know. It's just, I shouldn't have even asked.
Well, we started by talking about math and how you guys said that I didn't know what we're talking about, etc. Then we went into buoyancy and invoking G, which we thoroughly destroyed, but you guys don't accept. Then we moved into the derivation of G, which we had to invoke Newton's law of gravitation with, of course, that's where it came from. But then we went to the history of it. So we showed how Newton actually bogarted Kepler's law, inserted mass with no dynamic reasoning, and then just kinematically put it back in, so that later people today who know algebra, right, can remove it again the same way kinematically and then show you that it is no dynamic cause of anything. Just for a summary. Anyone else got something to say? I think I'm good. Sorry to take up so much time.
Hey, that was good, Shane.
Nice job, Shane.
Oh, Glory. Hey, what's up, man?
Can anybody else explain what he said?
Please.
Can anybody put it into English that any other human being can understand? I'd love to hear you try.
Did you want to try?
I'm really trying. I don't know. They need to use Feynman, Feynman's a good word.
He's speaking at a pretty high level, so I doubt very many.
Yeah,
can.
Lower it for us, because we're just globies. We're very dumb, Lower it.
You could try to go through the sources, right, which I definitely cited on this kinematic and dynamics equivalence tab of the published database, which is the tools that I usually beat people with, but no one wants to look at.
This is talking about orbits, man. How are you a glober and you're using equations talking about orbits?
I'm not a glober.
A flat Earth. I'm sorry. How are you a flat Earth? This is talking about orbits.
Things in the sky move, dude. Move with a specific periodicity that can be predicted. Hence the first conversation about the eclipse cycle that we all started with.
Wait, it can't be predicted? You just said you can. I'm pretty sure someone just gave me a spreadsheet that they can. The fuck?
No, I said definitely can predict it. That's my spreadsheet, right? That's what we started with. That's how I brought it in. Right. Well, orbits came from observations, right? Optics. Tycho Brahe put all those observations to get to the paper. And then, of course, Kepler came along to steal them before Newton came along to insert erroneous mass into that equation to trick the whole world.
Wait, what were they looking at?
Is this true?
The paths of the lights in the sky. Yeah, absolutely. This is how you derive ellipticity, right? When you have to produce ellipses because you need ellipticity.
And what are those lights in the sky doing?
Moving.
Oh.
Are they moving in orbits?
The moving in patterns, certainly, yeah.
Are they in
Right.
orbits?
Do you think that the star trails that never moved debunk our position, or what?
I was just wondering what they were looking at. What do you think they were looking at?
You think light are waves or a particle?
The
I think that's a
pathways of
better
the
question.
wandering stars, right? It's a well-known thing, and he was able to not only observe but predict. Essentially, he noticed the cyclical pattern, put it to a formula.
Mm-hmm.
And then we saw a wiggle in one of the movements, and we were like, huh, since gravity exists and these things are wiggling, there must be a planet over here. And then they found Neptune because they assumed gravity exists. That's, you can look it up. That's how they found Neptune. They assumed gravity existed, and then they found.
Max.
But you're applying history from this century to something that happened 4 centuries ago. Like, that's not at all how it happened in the order in which it occurred, right? First, it was Tycho Brahe, then Kepler, then Newton. And when Newton came along, when he invented calculus to mathematically bamboozle the world, right? Do a little joke over here, dun, 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 here's mass. Now everything that you predicted is the same thing that I predicted, but it's because of mass. That's literally what happened historically. Anyway, that's why we can do what we did today with that Newton's law of gravitational equation in the first place.
Yeah, but I'm saying that they saw variations in these orbits that are supposed to be very predictable, right? Like you're saying that they saw these orbits very predictable. And then they saw that one of them was like wiggling, like, hey, this is not very good. There must be a planet over here in order to explain this wiggle. And then they found Neptune. So,
well, I mean, how would that work then? If I can reduce that formula to not include mass, then how would you determine that at all?
Well, you have to explain it because you're the one saying, oh, like, there you go again. You're going straight back to equations. I'm saying, how do you explain the phenomenon? We were able to find a new planet based off of the variations of other planets. If gravity doesn't exist, right, and these are just predictive, straightforward patterns, how could you predict new planets?
Well, that's nonsense, right?
Neptune was founded by Galileo.
Well, yeah,
spotted, so it wasn't a new discovery. It was just a new category or a new designation for what that celestial was.
Plus, the gravity is based on mass, and they determine mass, which is a kinematic relation of this formula. So without this formula, you cannot determine mass, which cannot determine, say the supposed reach of gravity, which would defeat that whole thing. So it all comes back to this derivation of universal law of gravitation without mass.
I still want to know what orbits you think they saw. What was orbiting?
Is that your win?
I just want to know what you think they saw as an orbit.
Scott.
Yeah, Scott,
who are you? An orbit,
traumatized from the cartoons.
You've never seen an orbit, Scott, have you?
Not either with these people, according to Shane.
No one's seen an orbit.
Right, Shane says they did.
Yep.
He said movements in the sky.
He said orbits. We can play it back. Orbit. I know he said orbits.
It's not an orbit.
Bro, it's just going around. That's what orbit means.
Sorry, could I ask a question?
Okay, so wait a minute. So have you seen them orbit, dude? Diabetes?
Why would I see them orbit?
Well, to say that it's an orbit, you'd have to see them orbit, wouldn't you?
You have to see an air. I mean, we can feel it, right?
Well, you don't have to see...
Wait, you can feel... Wait, you can feel what?
But I want to...
Hang on. This guy's got something to say. What can you feel? Oh, he's been muted. Anyway. Go ahead, guys.
I wanted to ask which of... I don't know what that guy... I don't know if he was a flat earther or a rounder, but which of Kepler's laws was he trying to derive?
Who's Shane? Is Shane still here?
Yeah.
Shane, which of Kepler's laws were you trying to derive?
Third law.
Kepler's third law. And what was the point? Were you trying to show something with that? Just so I have more context?
Well, I mean, the point requires the explanation from the historicity standpoint, which we just went through, but I don't want to keep tying up the whole room with that.
Okay.
There's a nice post on Twitter where I outlined the whole thing from the beginning if you're interested.
Could you post that in the side chat?
Sure. Did anyone want to try to derive the radius of Earth optically again? Because I always thought that was a fun exercise. Right? Like, what if we say, like, there's no physical Earth curve anywhere? It's only ever been an effect of optics. And then we, like, prove it with math.
I would say you see boats going. Oh, actually, you prove it with math. That's right. I forgot. That's what it. It's just look at the equations. Don't look at physical phenomenon. That's right.
Well,
You can look at physical phenomena, but as I've said, if your measurements don't have any of the relevant statistical properties, then there's no real inferences you can make from them.
well, there is inferences you can make when you say the relationship between the angular resolution limit, optically, and then say the usual rate at which something would appear to drop over, say, 3 miles. And then using those two criterion, you can always derive the radius of Earth. Wouldn't that be weird? And then also, not that, right? But you can derive it to the 8th decimal point. So,
But all of your measuring tools have some degree of uncertainty, and you have to consider that, right? So if your expected value falls outside of the range of uncertainty, then you can conclude that these results are statistically significant. But whatever document that was sent doesn't have that.
well,
So it's just bad. It's bad methodology.
you're talking about like experiments and measurements and some sort of thing, but this is just like, there's no document. All it is the math describing the backwards derivation of just that. So, like, what would you need to show that that's how it was derived?
Well, but I'm saying that they took. So you can start with just an expected value, but the measurements that they took with their lasers, they don't have any uncertainty. So anything that they anything that they calculate using those, right? You're not going to be able to propagate that uncertainty to your final result. So once you do that, and the expected value falls outside of that range of uncertainty, then you can conclusively say, because for all I know, these measuring tools had a really big uncertainty. Let's say they had an uncertainty of 0.1 millimeters per, like plus or minus 0.1. That's a really high degree of uncertainty. So the expected value might fall, or sorry, maybe it has a small. What I'm saying is I don't know, so I can't know for sure. Comparing the calculated with the expected.
I'm just saying we see boats not disappearing, getting smaller, but just going bottom up, right? And no amount of equations is going to explain that. You have to explain that.
What do you mean no amount of equations could explain that?
Okay. Equations are used to describe, like, you have a hypothesis, you come up with an equation, and then you use that equation to predict new phenomenon, right? I think electrons are attracted to anything else that is not, they're not attracted to each other. So if I have a bunch of electrons in like a battery or something like that, I can put it up to like some kind of metal surface and measure the voltage. I can test it, right? And I can see how much voltage. If I have an equation describe how much voltage I think, I can measure the observed voltage and see if my equation lines up. But you have to have an observable phenomenon in order to do that. And what I'm saying is that boats are disappearing bottom up, and then you're looking at the equations and just going, well, mass doesn't exist. Like I can algebraically remove it. I could algebraically remove it.
Completely different equations.
Well, yeah. I'm saying an example.
Okay.
But by the way, I'm taking a look. Oh, sorry. Go ahead.
I was just gonna say I see your explanation, but like, how do you explain things going bottom up? I see them. I'm looking at them right now.
Okay. Why wouldn't they go top up?
Because the Earth is curving down, man. It's curving away from you.
Is that why? Or is it because the top horizon is a way further limit than the bottom?
The horizon isn't a limit. I mean, like the only reason that there's a horizon on a globe Earth is because there's the line of sight is tangent to some point on the circle.
And once again, we're not seeing the boat getting smaller. It's not like train tracks converging on a point. They're just going bottom up. It's the same size, just going bottom up. That's the phenomenon you need to explain.
Well, I mean, we've already explained it perfectly. Where I'm just trying to relay it to you succinctly using words. So
no, you're saying, oh, the top horizon has a larger vanishing point than the bottom horizon, right?
Well, we're starting with the basic premise of I asked why wouldn't it disappear top up, right? That was the start.
Yeah, and the answer to that was because it curves down.
Because it curves down.
Oh, it curves away from you. I say down just to get it through you, because you guys don't believe in away or like gravity. So,
well, like proportionally.
Have you got a measurement of curvature?
We've seen it. I can send. Yes, yes. There's
Go for it.
No.
videos and boats go bottom up. We've seen
Yeah,
it.
at what distance?
Okay, even if I provide the equations, you guys are going to look at the equations, analyze them, and then just do
No, I
some
don't care
math.
about the equation. The equation's in my head, so it doesn't
Okay,
really
then get
matter.
rid of the equation then. How do you explain bottom up? How do you explain the boats going bottom up if you don't care about the equations? In words,
Hey,
conceptually, how do you explain it?
in words, how else are you going to explain it?
Angular resolution threshold limit, right? Like when it decreases into the horizon, it becomes that much more unresolvable, right? And you combine that with the average optical drop rate at distance, and you have bottom up obstruction. Matter of fact, it could only happen bottom up on a flat Earth.